Hi, here to do the Algebra 2 notes on Chapter 1, Section 5 on solving equations. And want to first look at distributive property. Really, this section here is going to have three parts. And distributive property comes up over and over and over, so it's worth a quick review. Sections 2 and 3, there's kind of the book has ways that they recommend solving equations that have lots of fractions or lots of decimals. I'm going to give you the book's advice. Over the years I found most students just kind of hack their way through with a calculator and they do just fine. But Chapter 1, Section 5, solving equations. First thing, distributive property. And distributive property, if you want to write out the whole definition, you can. I'm not a huge fan of having you memorize definitions, but you sure need to know how to use it. But here's a definition that you once knew back in geometry class. It says for all real numbers a, b, and c, then they do something like a times b plus c, with b plus c in parentheses, that equals ab plus ac. And really what it's looking at is that when you have something like a times something in parentheses with a addition sign or subtraction sign, that really a needs to be multiplied times the first thing in parentheses and a needs to be multiplied by the second thing in parentheses. So ab plus ac. And I'm going to do a couple examples. So first example, I have this problem here, 2x plus 3 times x plus 5. And kind of added this in here for two reasons. One, the 2x isn't part of the distributive property. That when we look at this, the kind of clumps, the sections of the equation are always separated by an addition sign or a subtraction sign. So here we have 3 times this x plus 5 in parentheses. So we're going to have to do distributive with the 3. And one thing that's worth mentioning is that when we have this plus 3 times x plus 5, it's kind of like you have a positive 3 times a positive x times a positive 5. So if we rewrite the equation, or the mathematical expression, technically there's no equals, 2x, now we have 3 times x, so that gives me plus 3x, a positive 3 times a positive x gives me a positive 3x. And then we have a positive 3 times a positive 5 for a plus 15. And then last step is to simplify that this 2x and 3x, those are like terms. So if we have two of them, we add 3 more to it, we get 5x. And then we still have the plus 15. So that's the first example, pretty straightforward with that one. I want to jump down to the second example, so quick pause it if you're still copying. Example 2. The big thing with example 2 is the negatives. That negatives totally hose people. So I'm going to, in here, write be careful with negatives. Negatives are kind of like the thorn in people's flesh, that if I give them a problem with a negative in there, often they get it wrong. So please, those of you that are breezing through the notes, this here, you're going to get something like this on the first quiz, and often people mess it up. So okay, where do we do distributive? Here we have the negative 2 times this 5x minus 2. I never was a big fan of this. You could rewrite it this way. It's the whole definition of subtraction that they did in geometry class. I never was a huge fan of that. But there's merit to it, that when you see this 14 minus 2, it's kind of like you have this negative 2 times what's in the parentheses. So some people like that. I kind of always just thought that was extra work, and I'm just going to view it kind of like the way it is before. But you do need to know that when you're distributing the 2, that's technically, it's a negative 2. So we have this whole minus 2 then, that gets multiplied by the 5x and the minus 2 there as well. So then, switch colors. So if I rewrite my problem, I have my 14. Now I have a negative 2 times a positive 5x. So a positive and a negative give me a negative. And 2 times 5 is 10, so I have 10 x's. Now I have a negative 2 times this other negative 2 here. So negative times negative gives me positive. And 2 times 2 gives me a 4. So I end up with a positive 4. And then just like the last example, we can combine like terms. Well, when I have this 14 here, you always look at what's in front of it to get the sign. So it's going to be a positive 14. Nothing was written there. You can view it as though it's positive. So it's positive 14 and a positive 4. So we don't do 14 minus this 4. it's minus 10x. That's kind of its own separate little part there. But we have a positive 14. We're going to combine that with a positive 4, which gives us then a positive 18. And then we have this minus 10x. So that would be the simplified final answer for example 2. That's the distributive part. Like I said, this next part here then, moving on, I'm going to call it Roman numeral 2, is something that I'm going to give you the books method. A lot of people, they just kind of hack their way through it, and I'll mention how you can do that with a graphing calculator, since a lot of you are new to graphing calculators this year. But the books method, and if I were you, I probably would just watch and don't bother writing all this stuff right off the bat, or you could if you wanted to. But the book says multiply all parts of both sides, and underline the both sides, and the all parts, because people make a mistake doing the book's way. It's usually they don't multiply all parts of both sides. They forget a side or they forget a column. But multiply all parts of both sides by the least common denominator. So multiply all parts of both sides by the least common denominator. And then for that, the example I'm going to go through is this one here. So I'll throw in an example. I'm going to have it be 1/6 x plus 3/4 x. And then plus 2. This is going to make it look like one of the examples in the book, that there's one in the homework very similar to that with a farmer's field. So you may want to kind of kick back, check out that example. I don't remember which example it is off the top of my head. Sorry, can't give you that. Now we're looking for the least common denominator, so 6 and 4, saying what number do they both go into. It doesn't need to be the least one. You could multiply all parts of both sides by, say, 24. It's just going to give you bigger numbers that you need to work with. But the least common denominator is going to be a 12. 6 goes into 12, 4 goes into 12. So I'm going to say I'm going to multiply all parts of both sides by 12. And this 2 here is what people forget. Or they don't do 4 times 12, they just make it equal 12. And multiplying fractions stresses some people out, but if you look, it's really not that bad. You have 12 times 1, 12 divided by 6 gives you 2. So 12 divided by 6 is 2, so that gives me a 2x. 12 times 3, 36, divided by 4, that'd be 9. So 9x. And then 12 times the 2 is positive 24 equals 48. And now we go through and combine like terms. So now you treat it just like a normal problem. So you have 11 x's total plus 24 equals 48. Then subtract 24 from both sides. And you have 11x equals 24. Divide by 11, divide by 11, and then x is going to be, oh shoot, didn't write the answer in my notes. Let me quick find this sucker. So 24 divided by 11, 2.18, with a little bit of rounding, so 2.18 would be the final answer. That said, that's the book's way that they recommend doing it. Here's how pretty much everybody does it in the real world. When you have 1/6 x plus 3/4 x plus 2 equals 4. That if you're afraid of working with fractions, yeah, this is going to stress you out a little bit, maybe. But your graphing calculator is nice. It'll do the work for you. The safe way to punch something in with fractions, you don't always need it. In this case, you actually don't need it. But the way I tell people, if you don't want to think about it, it's safe to punch your fractions into a graphing calculator by putting a fraction inside parentheses. So if you do parenthesis 1 divided by 6 parenthesis, that basically gives you the equation 1/6. I'm just going to do that here, 1 divided by 6 in parentheses. And then plus, left parenthesis, 3 divided by 4, right parenthesis. Press enter if you want to, you get some ugly decimal. Some people will go through and do this decimal. That'll work as long as you carry your decimal out to all the digits or a lot of digits or use your answer key over and over. That's fine. But if you take this one here and round it to say 0.92 or 0.9 and then go through your problem and say 0.92 plus 0.92x plus 2 equals 4, subtract 2 from both sides, divide by 0.92, you're going to be close, but you're not going to be exact. If you want to be closer and actually get full credit in my class, you could. If you didn't punch it in, your screen says 0.916666666, a whole bunch of 6's with a 7 at the end, which is the calculator's way of saying the 6 is repeated, and then they just round for the last digit on the screen. So you could do that same thing, divide by, subtract 2 from both sides, and then when you have 0.916 repeating x equals 2, you could do 2 divided by 0.91, then hit the 6 button a whole bunch of times over and over. It's going to work. The other way is when you're on your screen. So let's say you just typed in this 1/6 plus 3/4, and you get that decimal. If you ever want to take a decimal and change it back into a fraction, here's the key sequence that you do. And you could have pressed enter first, but if you take and look near your second button, it's 2 below the second button on your calculator, you have this button called math. If you hit that math button, the first option that's highlighted right now is going to be a little arrow that says arrow frac. So it's saying it's going to take whatever is before this in your line in your calculator, or whatever your answer was the line before, and going to change that into a fraction. So if you take and do your math button and then enter, once is going to select it, and then a second time, so math enter enter, the second time you press enter, it's actually going to run the equation. So if I do that with my calculator, where on the screen I had 0.91666666666, I do that math enter enter, it changes it into 11/12. So then if you wanted to, you could say you have 11/12 x plus 2 equals 4, subtract 2 from both sides, and then you end up doing 2 divided by, and then it's always safest to take and do a fraction in parentheses. You could do 2 divided by parenthesis 11 divided by 12 parenthesis enter, and you should get this same exact 2.18 repeating because you kept it as a fraction. Okay, so that's one trick. The other one, and a little bit simpler, maybe I should have done it second, is when you have decimals. And the book seems to think that decimals are really hard for people. Generally they're not. Pretty much nobody ever uses the book's method on this one. What the book says is multiply, I probably should write it, multiply all of both sides, multiply all parts of both sides by a factor of 10. So multiply it by 10 or 100 or 10,000 or 100 million or something like that. And what they're really trying to get you to do is the number of zeros. So 10 would be 1 0, 1,000 would be 3 zeros, 100 would be 2 zeros. The number of zeros equals the max number of decimal. And this one is a lot shorter of a problem. So if I have 0.02x plus 0.005x plus 4 equals 32. If I look, I have 2 decimals here. So 0.02x, I have 2 decimals. 0.005x, I have 3 decimals. No decimals with the plus 4 or the 32. So I'm going to multiply by a 10 or a 1 with 3 decimals because of my 1, 2, 3 decimal points there. So I multiply all this side by 1,000, and this side by 1,000. What that's going to do is it's going to take and hop that decimal point 3 places. So maybe let me do that here. So 1, 2, 3 is going to get me over there, which is going to end up being 20x. When I hop my 3 decimal places here, I have 1, 2, 3. So that gives me a plus 5x. We'll just leave it in red. My 4, multiplying by 1,000, moves it 3 places. So now I end up with 4,000 equals 32,000. And then it looks way too much like 33. So 32 comma 0, 0, 0. And now you can go through like normal, subtract 4,000 from both sides, combine the x's, you get 25x. I probably should actually do the work. Call it good modeling. So 25x plus 4,000 equals 32,000. So if I subtract 4,000 from both sides, I'm running out of space. I'm just going to write that as 28,000. So subtracted 4,000 there. Now I have my 25x. So I divide both sides by 25. So 28,000 divided by 25. I get 1,120. So 1,120. In the old days, that maybe was the best way to go. For now, people just use their calculator. If they have this 0.02x plus 0.005x plus 4 equals 32. Actually, a lot of us maybe don't even use our calculator. But you could. You could go through and say 0.02 plus 0.005, and I have 0.025. So you could say, all right, so I have 0.025. That's how many x's I have, plus 4 equals 32. Subtract 4 to get 28. You have 0.025x. Divide both sides by 0.025. You can do it. It's really not bad at all. Some people, though, without even using their calculator, they say, well, hey, my 2 is going to be right there. So it's 0.0, and then that would be 2, and 5's after it. So you don't even need your calculator until perhaps that last step. That's all from Section 5.